welcome to Hoya Robotics. This is one of our training videos and it's assembly part 1 and dealing with hand tools. I want to thank our sponsors from the 2019 and 2020 seasons, and we will be updating this video later with our new sponsors for the 2022 season. Safety first. Whenever we are using tools, we always want to make sure that we are wearing safety glasses. We're going to secure our loose hair and clothing and wear closed-toed shoes. With fastening things, these are our most common fasteners. 1032 socket head cap screws. We get those from Fastenal, and the 1032 nylock hex nut. And these are used to hold metal pieces together. This is our most common fastener that we use on our robots. We do use other bolts. So for example, Neo 550 motors use M3 bolts. M4 motors use M4 bolts are used to hold 775 Pro motors. Our Thrifty Bot bearing blocks that we use for our drivetrain use number 832. And we often use a 1/4-20 for elevators. They are thicker than the 1032, so they're used when we are going to have a strong load that could possibly snap a 1032. We sometimes use flat heads countersunk bolts, so they have a smaller hex size, and we use those, for example, in Excalibur, our 2019 intake system. The bottom, we didn't want the bolt heads to interfere with the balls, so we used polycarbonate and used a countersunk bolt so that it would be flush. In room 102, we keep all of these parts in the pack out on the work table, and there's a 1032 pack out, so all the different lengths are in there. This is the color coding that we are using, so if you are looking for the particular things, we are using blue for 1032 bolt sizes, and then the tools such as the Allen key and the socket will be blue as well, so that it's easy to identify which tool to use. The Allen key is a 532, and the wrench or the socket that we need is a 3/8. For fastening, the standard tool to use is the Allen key, so that's a 532-inch hex key. You'll notice that it's an L shape, so if you put the short end into the bolt, that gives you lots of leverage. And if you put the long end in, you'll notice that there's a little ball at the end. That allows you to angle the Allen key, so if you're in a tight spot and just don't have the space, if you can possibly angle it, that might make it work. And then we use the ratchet to actually turn the nut. So the goal with the Allen key is just simply to prevent the socket cap from turning, and then we'll use the ratchet to turn the nut and use a 3/8-inch socket on the ratchet. At the head of you can't see it, but on this side, there's a little thing that you press to be able to pull the socket off and put it on. That's the socket. And there's a little dial that allows you to change the direction. So if you spin it, you can see which direction it turns. And then this is the handle that allows you to, when you push that will start spinning it. And there's some little lights and LED lights that when you're running it, you can check to see the status of the battery, so you know if you need to plug the battery in. All of these tools are kept on the upper deck in room 102. So the hex keys and the sockets are in the blue tool chest, and the ratchet is in the drill stand. And for those of you on the robotics team, we also have separate tools in the other rooms so that we use those in the pit. Just remember, right is tight and left is loose. So when you're spinning it, if you're looking at it when it's turning right, that means that the bolt will be tightening, and when it's turning left, it's going to be loosening. So always check before you connect it. A couple tips: you want to make sure that you finger tighten the bolt so that way just the parts are on. You start that, then you use the ratchet. Really be careful not to over tighten. If you are starting to indent the metal, then it is too tight. Everything should be snug, but it should not be deforming the metal, because then other things might not fit. And the end of the nut should be flush with the end of the socket cap screw. If it's not, so if you don't need any more than that to be able to secure it, and you don't obviously want less than that. So talk to the designers. Maybe they didn't account for the thickness of the material, so you want to make sure that you got the right size. Keep all of your parts organized, and you want to make sure that somebody helps you hold it. And if something doesn't fit, don't hammer it. So, for example, maybe the hole wasn't drilled to the right size, or maybe when somebody was drilling holes, they didn't position it properly. Figure out what the problem is. Do we need to redesign it? Do we need to remanufacture it? Before, we don't want to just hammer things in. The other thing is that think about how you're putting in a part. So for example, if you have a 6 bolts that go in, you put this bolt in first, and then this one, and then this one, that one, that one, and that one. And that way you're balancing the loads so everything is lining up. Now, I often see people use like an Allen key and a wrench, and we tend not to do that. And the simple reason for that is it takes a long time. The electric ratchet really helps with getting that done. There's a variety of other tools that we use. So for example, our T-handle hex, we often use for spots where we need that extra length. The Allen key just simply won't fit. The manual ratchet, instead of the electric, sometimes we'll be using that. The nut driver, and again, if the ratchet doesn't fit because of the angle and stuff, having the straight nut driver can be a real bonus. And then we also have the flexible shaft bit holder, so that we can put a hex bit on the end, and use the impact to control it if need be. The last thing is, always make sure that you put your tools back at the end. Thank you very much.